This lesson is on identifying conic sections. How do I determine whether the graph of an equation represents a conic? And if it does, which conic does it represent? A circle, an ellipse, a parabola, or a hyperbola? The general form of a conic equation looks like this. ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. This is called general or implicit form, where a, b, c, d, e, and f are integers, and a, b, and c are not all equal to 0. You may see some conics solved for y, but if the equation can be rewritten in this form, then it is a conic equation. When you say a, b, and c are not all equal to 0, some of them can be equal to 0, but not all of them at the same time. A conic equation written in general form doesn't have to have all 6 terms. Several of the coefficients a, b, c, d, e, and f can equal 0, as long as a, b, and c don't all equal 0 at the same time. What do you think would happen if a, b, and c all equaled 0? Well, think about it. If a, b, and c are not there, then all we have is dx plus ey plus f equals 0. And this is just a linear equation because the x and the y, their exponent is equal to 1. This is a degree 1 equation. So, it's a conic equation if the highest degree or power of x and or of y is 2. At least one of these two variables has to be squared. Also, the other terms are either linear, constant, or the product of x and y. And there is no variable term with rational exponents. In other words, no radical expressions. They don't have terms with negative exponents. No rational expressions. The values of the coefficients in the conic equation determine the type of conic. Notice that the word underlined is coefficient. So we're going to look today at what values form an ellipse, what values form an hyperbola, and what values form a parabola. For ellipses, if ax squared plus cy squared plus dx plus ey plus f equals 0, and a and c have the same sign, then we have an ellipse. Please note that there is no bxy term, and d, e, and f may equal 0. So for example, 2x squared plus y squared plus 8x equals 0. Also, negative x squared minus 2x minus 3y squared plus 6y equals 0. Also, 2x squared plus 2y squared plus 8x minus 6 equals 0. Notice in each of these examples that the a, which is the x squared's coefficient, and the c, which is the y squared's coefficient, are both positive. They have the same sign. In the second example, the x squared term has a coefficient that is negative, and the y squared term has a coefficient that is negative. In the third example, the x squared has a positive 2, the y squared has a positive 2. All the same sign. Both positive, both negative, both positive. These are all ellipses. The general or implicit form of the equation can be converted to graphing form by completing the square. This is what we've been calling standard form, and dividing so that the constant is equal to 1. We've been doing this all along. So here's an example of changing from the general or implicit form to the graphing or standard form. You can pause and try this on your own, look at it, see what questions you have, and we'll discuss this in class on Tuesday. This is an ellipse, you can see, because both x and y are squared, and x squared has a coefficient of positive 2, and y squared has a coefficient of positive 1. They both have the same sign. Okay, in this example, x and y are both squared, and they're both negative. Still the same sign. -1, and -3. You can see in the final step that when we divide by -4, all the terms are positive. A special case of the ellipse is when A and C are the same value as well as the same sign. The ellipse is the same length in all directions. That means it's a circle. So in this example, 2x squared plus 2y squared plus 8x minus 6 equals 0. The x squared and the y squared, the A and the C, are both positive and they're both 2. This means it's a circle. The hyperbola. Ax squared plus cy squared plus dx plus ey plus f equals 0, where A and C have different signs. Note that there is no bxy term, and de and f may all equal 0. Here are some examples. 9x squared minus 4y squared minus 36x minus 8y minus 4 equals 0. The A and the C have different signs. The A is positive, the C is negative. X squared minus y squared plus 6y, minus 5 equals 0. The x squared has a positive 1 coefficient, the y squared has a negative 1 coefficient. Different signs. X squared plus 10x minus 4y squared plus 8y plus 5 equals 0. X squared has 1, that's positive. Y squared has negative 4, that's negative. Different signs. So it's an it's a hyperbola. The general or implicit form of the equations can be converted to graphing or standard form by completing the square and dividing so that the constant is 1. In this example, the signs change, but since the quadratic terms still have different signs, it is still a hyperbola. A parabola can be oriented two different ways. A parabola is vertical if the equation has an x squared term and a linear y term. It may or may not have a linear x term and a constant. So ax squared plus dx plus ey plus f equals 0. A parabola is horizontal if the equation has a y squared term and a linear x term. It may or may not have a linear y term and a constant. So cy squared plus dx plus ey plus f equals 0. The following equations all represent vertical parabolas in general form. They all have a squared x term and a linear y term. Squared x term and a linear y term. Squared x, linear y. Squared x, linear y. Squared x, linear y. A parabola is vertical. To write the equations in graphing form, you're going to complete the square for the x terms. There are two popular conventions for writing parabolas in graphing form, and both are given below. This form we used, called it vertex form, and in Algebra 2 we used this one the most. This is the form that we've been using in our class. We've been putting the x minus 2 squared on the right-hand side and the y minus 3 on the left. In this example, the signs must be changed at the end so that the y term is positive. Notice that the negative coefficient of the x squared term makes the parabola open down. Horizontal parabolas. The following equations all represent horizontal parabolas in general form. They all have a squared y term and a linear x. Squared y, linear x. Squared y, linear x. Squared y, linear x. Again, to put the equations in graphing form, you're going to complete the square for the y terms. And again, there are the two popular conventions, the vertex form and then our standard form. Okay, again, in this example, the signs must be changed at the end so that the x term is positive. Notice that the negative coefficient of the y squared makes the parabola open to the left. What about the bx term? Well, none of the conic sections or conic equations that we've looked at so far included a bx term. This term leads to a hyperbolic graph. 4xy minus 8 equals 0, or if we solve it for y, add the 8 to both sides and divide by 4x. So 8 divided by 4x is the same as 2 divided by x. So here's a quick summary. The general form of a conic equation in the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where a, b, c, d, e, and f are integers, and a, b, and c are not all equal to 0. Okay, a parabola, if a equals 0 or c equals 0, but not both. If a is 0, then the parabola is horizontal. If c is 0, the parabola is vertical. If a is equal to c, the conic is a circle. If a and c have the same signs, but they're not the same number, it's an ellipse. And if it's a hyperbola, a and c are going to have different signs. Here's some practice problems I'd like for you to try. So identify each of the following as an ellipse, circle, hyperbola, parabola, or not a conic. Pause this video, try them, and see what you can do. On the next slide will be your answers. Here are the answers to the practice problems. Pause the video and check your answers. That's it for conic sections.